moving right along with transformations. Today we're going to talk about a dilation. So if you've ever gone into a dark room and then checked your eyes to see how they look, your pupils will enlarge, and we say that they are dilating. A dilation means we are either getting bigger or smaller. We're making the shape change. So, for example, this is a very practical topic. So if you've ever played with Hot Wheels before, you know that they are a small version of a real vehicle, right? And how do they make those tiny versions of the real vehicle? Well, they used the scale factor. They dilated it and made it smaller so you could play with it. And so I mentioned a scale factor just now, and this is what we use to make something larger or smaller. Proportionally, right? The Hot Wheels still looks like the actual vehicle because it was reduced proportionally with respect to a certain point. So in this picture we have point C, and the best way that I can explain this point is, if you've ever been in a dark room again, we used a flashlight, right? And so let's say that we have a flashlight here and we turn it on. If you've ever turned on a flashlight, you notice that the light is moving kind of like getting bigger as the farther it is, right? If you have a flashlight, you turn it on towards the wall, you walk closer towards the wall. If you notice, the circle on the wall is going to get smaller as you get closer to the wall, and if you walk further away from the wall, the circle becomes larger. And so that's kind of the same mindset. So a dilation starts at a point, let's say at the beginning of the flashlight, and the farther you go, the bigger it gets. The closer you get to the flashlight, the smaller it gets. And so that's what we mean by the center of a dilation. So let's think of this point C as the starting point, or the flashlight. And as you can notice, this triangle is getting bigger, transformed to be larger the farther the lines go, and it gets smaller the closer it is to the point C. And once again, to make the shape larger or smaller, we use a scale factor to do that. So now, what does it mean if we have a large number? Let's say that you want to scale it by 2. If you have a whole number that you're going to be multiplying, this would be your scale factor. If 2 is your scale factor, then that means that you're wanting to enlarge the figure, right? If anything greater than 1, so right here, anything if K, and we use the letter K to represent our scale value. If K is greater than 1, then it means we are enlarging it. If, on the other hand, you're not given a whole number, you're given a fraction, let's say 1 over 2, that's your scale factor. That means we want to make it half times smaller or 2 times smaller than the original figure. So if it's a fraction or anything between 0 and 1, then that means we are trying to reduce the picture, making it smaller. Okay? So let's do an example in real life, because like I said, this is a very, very practical topic, especially for those people who work in engineering and things like that. They always first create a model before they actually create the real life thing that they're trying to construct or invent. So let's do this example here. It says to create different size prints, you can adjust the distance between a film negative and the enlarged print by using a photographic enlarger. So you want to make the picture larger. Suppose the distance between the light source C and the negative is 45 millimeters. 45 millimeters. So that means here's CP, and I'm going to use blue. So CP is 45 millimeters in length. To what distance P to P prime? I'll use yellow here. To what distance does P to P prime should you adjust the enlarger to create a 22.75 centimeters wide print? So the picture is starting from right here in green. The picture originally is 22.75 centimeters. And you want to grow it down here. You want it to grow it to 35 millimeters wide. So how can we do that? So what distance does P to P prime have to be to make that happen? Well, what we're going to do here is we're going to try to find the scale factor that is being used. And we can compare two things in particular. We know where we are starting from. We know it's 22.75 centimeters, and we know where we want to go. We want to make it 35 millimeters in length. So we can, first of all, we have two different measurements, right? We have a centimeters and we have millimeters. So let's make them both millimeters. And so we're going to go ahead and change. And you can find this on like a Google converter. But this, we're going to change it to 227.5 millimeters. That's where we want to change it so that we have the same units. Because if you're not using the same units, we're going to get the wrong answer. So what's going to be my scale factor? So to find my scale factor, I'm going to see from where to where did we go. So to do that, I'm going to write it as a fraction. So I'm going to put 227.5 over 35. So to find the scale factor, you will divide the two numbers given. And once we divide this, we get 6.5. So my scale factor is 6.5. So they got larger, right? By 6.5. So that's how much bigger we want it to be. We went from 227.5 millimeters to 35 millimeters. That's where we want to go. And that means we want to make it 6.5 units larger. Now that we know this, we can apply this. Remember, to make something larger, we multiply it by the scale factor. So we're going to multiply C to C prime, the 45 millimeters, by the scale factor, and it's going to tell me how far away. So if I multiply C to C prime, this part right here, the whole thing, I'm going to multiply C to C prime, so 45 times the scale factor, and it's going to give me the distance, the entire distance from C to C prime. Okay, so we're going to find that red line. So what we're going to do is we're going to take the scale factor, which is 6.5, and we're going to multiply it to the distance C to C prime, C to P prime, sorry. So actually C to P, right? And once we do that, now what's C to P, right? C to P is 45 units. So I'm going to go ahead and erase this and put 45, because then this is going to be able to help me answer my problem here. So we know that from C to P it's 45. To find how much bigger it's going to get, we're going to multiply those together, and we're going to get 292.5. So that's the total distance from the very top to the very bottom. But that's not the whole distance, right? We don't want the whole thing. We only want the yellow part from P to P prime. That's what we're concerned with here. So since we know the entire distance, 292.5, right? We know the entire distance. We're going to go ahead and subtract, before we do that, I want to show you what I mean by this. So 45 plus whatever it is that we're looking for should equal 292.5. That's the entire distance. We don't want the entire distance. We're looking for the yellow part. So what we're going to do is we're going to subtract 45 from the entire distance to get what we're looking for, to get our final answer, what we're looking for is P to P prime. What distance is P to P prime? That's what we're looking for. And when I subtract those two numbers, I'm going to get 247.5. And this is all in millimeters. And that'll be our final answer. This is how far P to P prime has to be so that our picture is enlarged 6.5 times bigger than what it originally was. So I hope you can see how practical this topic is, and I hope this helps.